Given here is a rational function, find our horizontal and vertical asymptote if any. So to find vertical asymptote, we will start with the function undefined. Since this is a rational function, so function will be undefined when the denominator equals to 0. So we figure out the x value that we want to calculate here. So x will be equals to 1, x will be equals to 2. So these two values, it can be our vertical asymptote. To verify this is a vertical asymptote, we using the concept of limit, calculate it from the left hand side. And also calculate this x approaches 1 from the right hand side. For another point, when x approaches 2 from the left hand side, and x approaches 2 from the right hand side. So how to do this? It will be try to substitute the value first. So when we substitute x equals to 1, actually it gives us value of 8. Then equals the denominator equals to 0. So when we having 8 over 0, the calculation will bring us to infinity. So whether positive infinity, we have to test with your calculator. So test with x. 1 from the left hand side means 0.9. So substitute the denominator, which is 0 here, 0.9. Once we put this x 0.9, we will notice that our answer is 0 point something positively. So positive over positive, we're getting positive infinity. Then we continue to find, evaluate this limit approaches 1 from the right hand side. Same procedure, we substitute 1. Then when we get a number over 0, it actually is an infinity. So from here we test 1 from the right hand side. So we can test with 1.1. So when we setting 1.1, it will getting the value of negative 0 point something for this denominator. Substitute at the 0 part here, so that we can identify this 0 is negative 0 point something or positive 0 point something. So negative 0 point something, when we having negative, positive over negative, it will be negative. Then substitute value of 2. Another point here, when you substitute 2, it is also happen in 11 over 0, so it will be infinity. So for 2 for the left, we will test with x equals to 1.9. So 2 from the left, when we test with 1.9, the denominator here will be negative 0 point something. So positive over negative, answer is negative infinity. Then approaches 2 from the right hand side, also substitute 2, getting same 11 over 0, which is infinity. Now we want to test value when 2 from the right hand side, 2.1. So we will put in your denominator here. So we get positive. Therefore, overall for the fraction, positive over positive, positive infinity. Once we get our answer, you can see approaches 1 left hand side, approaches 1 right hand side, answer is infinity. Approaches 2 left hand side, approaches 2 right hand side, answer also infinity. From here we can prove that actually the value x equals to 1 and the value x equals to 2, they are vertical asymptotes. Then we proceed to another part, which is finding horizontal asymptote. For finding horizontal asymptote, we need to calculate limit approaches negative infinity and limit approaches positive infinity for the function. As we try to substitute infinity, we get infinity over infinity, so it is IDF. To simplify this IDF, we will divide with the highest power of x. As you can see, all here will be polynomial only, so divide the highest power will be x squared. So once we simplify, and we can start evaluate this limit. Substitute infinity, so 3 over infinity 0, 5 over infinity also 0 over 1. So this one 3 over infinity 0, 2 over infinity square also 0, so 0 over 1, answer is 0. So when you limit approaches x from the right, from the positive infinity, approaches positive infinity, substitute infinity, it will be also IDF, so we simplify with divide by x squared. So this procedure just we done it before, so we take the simplest form that we already divide. And we evaluate this infinity, substitute the infinity, we get 3 over infinity 0 over 1. So both answer is 0, means y equals to 0 is horizontal asymptote.